If you'd like to understand how to get every mark in this difficult moments question, then make sure to hang around to the end. Welcome along, physics fans. In this question then we have to find the tension in this wire, and one of the things about this question is that the previous part has asked you to talk about the law of moments, so a bit of a clue really is what you've got to do with this question. So in this question then we have a shelf which has a mass of 2 kilograms and a vase on the end of the shelf which has a mass of 0.65 kilograms. Everything's in equilibrium and we've got to find tension there, and you can see we have a pivot point where the shelf hits the wall, so that's the only kind of pivot that we have. So first up, let's remind ourselves, or let's see if we can identify what forces we have in this diagram that can be considered to creating moments. So first up then, start with the easy one. We've got the vase here on the end which has a weight going downwards, and that mg for the vase is going to create a clockwise moment like this, and it's going to be clockwise because the pivot is down the other end. Next up, students tend to forget this one, that the actual plank itself or the shelf itself is nice and regular and has a centre of mass which will be acting here. So now we can say that the 2 kilograms of the shelf acts straight downwards, the weight of the shelf acts at that point there. So that too is going to create a second clockwise moment around the red pivot point. So in order for this to be balanced, there must be a third force acting somewhere that is going to create an anti-clockwise moment, and you would think, well, that's just going to be at this point, and you'd be right, it is going to be at that point. But you might think, well, it's just going to be the tension in the wire there, but it isn't, of course, because the definition of a moment is that the force that's creating the turning force has to be at right angles to the distance from the pivot, and that, however you look at it, that yellow force there is not at right angles to the pivot. So what in actual fact we need is a force that's going up like this. Now that is a force that is perpendicular, it's acting at the same point, and I would say that is going to be called Ty, which is the vertical component of the tension in the wire, and that is what is going to be creating the anti-clockwise moment. So we now have 3 moments in this diagram. The blue one and the red one added together will equal the gold one. So let's go ahead and put some numbers onto these now. We always know, of course, that the moment is going to be force times distance perpendicular. So let's do the shelf first. So for that then we're going to have the mass times g for the shelf, which is 2 times 9.81 times the distance, which is 0.25 meters. Then for the vase, we're going to have a distance, no we're not, we'll start with the force. The force is going to be 0.65 times 9.81 times the distance, which is going to be 0.5 meters, disappearing under the red arrows. Take away this distance here, so 0.45 meters. That's its distance to the pivot point at the end here. So if we add those two together, that has to equal the yellow anti-clockwise moment, which for us is simply going to be Ty times 0.3 meters. It tells us there 0.3. So we are now able to use this lot to get us a value for Ty, and then from that we can get a value for T that we actually want. When you put in the numbers into your calculator, you will get here that Ty times 0.3 is going to be equal to about 7.77, and some other little dobs that we're not interested in terribly. And that in itself tells us a value for Ty, or implies that Ty is going to be equal to 25.9 newtons. But that of course isn't the answer. That's the value for Ty. So this point now that we have to do a little bit of trick, because we're after T, remember, not Ty, and Ty is a component. So loads and loads of ways to think about this. You could just say to yourself, well, if I know this is 30, then this angle here must be 60, in which case Ty is going to be equal to T cosine 60. That's probably what I would do, to be honest. Therefore, taking that, we can now say that T cosine 60 is equal to 25.9, which implies that T equals approximately 52 newtons. Just very quickly, if you didn't like the way I did that trigonometry bit at the end there's our tension. That's what we're after. We know we have an angle here of 30, and we know what TY is, which is that one there. Well, we can bring TY over to this side. Remember, you can just move vectors around. So that's TY. And then we can say that TY and T are related by the fact that TY is opposite the angle. So that means that TY is going to be T sine 30, which is the same as T cos 60. So that's another way to do that angle if you are concerned by it. If you found that video interesting, try out this one.